In this recording, we'll work on some examples dealing with Coulomb's law and the interaction between charges. Remember, we saw this slide before. The expression for the force acting on two charges, or the force that two charges experience because of each other, is K, Q1, Q2 over R squared. And I'm using the absolute value here. Now, that gives us the magnitude of the force. Q1 and Q2 are the amount of charge, and R is the separation between the charges. And K is a constant. It's 9 × 10⁹ Newton meter squared per Coulomb squared. And to find the direction, and we are going to see that through the examples, we take into account the fact opposite charges attract and like charges repel. Okay, now a few things here just before getting into the directions. When we double one of the charges, okay, remember what's going to happen. When we double one of the charges, because the force is proportional to Q1, Q2, then the force is going to double. When we change the sign of one of the charges, okay, what's going to happen? If they were attracting before, they will repel. If they are repelling, they are going to attract. So it changes sign. Direction. When you change the sign of both of them, okay, that's going to be the same thing. Nothing is going to change. Why we will not have any change? Because if they were attracting before, when we change the sign of both of them, they are going to still attract. If they are repelling, if we change the sign of both of them, they are going to still repel. Now, what about if we double the distance? If we double the distance, recall the force is proportional to 1 over R squared. Now, R is squared and it is in the denominator, so the magnitude of the force is going to be 1/4 as much. If we double both charges, go back to the same expression, so it's going to be 2 for one and 2 for the other one, so it's going to be 4 times the force. Okay, that's a qualitative analysis of what's going to happen to the force. Now let's start with the questions. One of the typical experiments that's done usually in high schools, colleges, is to have what we call a Van der Graaf generator, and so which is made up of a rubber belt that's going to rub against some material, usually wool, and picking up charge in the process, and that charge is transferred to this dome. And usually we have a student, preferably with long hair, long thin hair, and hair that didn't have many products on it, long clean hair. Now stand isolated from ground and touching the dome. Now each strand of the hair, you see them moving apart. What is it trying to do? Why is it moving apart? Now we know the sphere, in this particular case, they tell us it is giving the girl a large negative charge. So what's happening here? What's happening is each strand of hair is going to gain a negative charge. Think of it like the vanes of the electroscope. What happens to the negative charges to the vanes of an electroscope when they both get the same charge? They move away from each other, like you see the strands of hair here. That's what's happening. Okay, now let's start discussing directions. What is the direction of the force on the proton due to the electron? Okay, the proton is obviously the positive charge. Okay, and what's the electron doing? It is attracting it. So the force is going to be in this direction. So our force is towards the right. Now we have a positive and a negative charge with equal magnitude. Okay, positive and negative charge with equal magnitude that are connected by a rigid rod. That's what we have. And placed near a large negative charge. That's what we have here. What is the net force on the two connected charges? Okay. What is the net force on the two connected charges for this configuration? Now these are equal magnitude charges. And it is asking us about the net force. Is it 0? Is it to the left? Is it to the right? Okay. Now here, to do that, we are going to consider the forces acting on each of the charges. The force acting on the positive charge is attractive, so it's going to be pointing towards the negative charge. The force acting on the negative charge is going to be repulsive, so it's going to point this way. Let's call this F1, and that one is F2. Okay, now they are opposite. Are they going to be equal to each other? No. Why no? Because of the distance. This is further away than this one. That means that this force is much weaker than this one, so my net force is going to be in the same direction as F1, since F1 is larger than F2, so my net force is towards the left. Okay, let's start having some fun, some calculations. Now, one of the things that we are going to need to be doing in dealing with electrostatics, we need to refresh our math skills, especially our use of vectors and addition of vectors. And this is going to come into play here. Okay, we have a 2 microcoulomb charge on top here. And we are asked to find the force acting to the 2 microcoulomb charge due to the two other charges. It's going to experience a force due to the plus 7 microcoulomb charge and another force due to the minus 3.5 microcoulomb charge. Okay, now before doing anything, I'm going to calculate the magnitude of each one of these forces. Okay, the magnitude, okay, let's call this 1, 2, and 3. The force exerted by charge 1 on charge 3 is going to be given by K Q1 Q3 over R squared. Okay, now remember we are doing the absolute values, trying to find the magnitudes. Now what would R be? R would be the distance separating them. That would be R. Now, since this is halfway, we have 3 meters here, 4 meters here. So R, we use R squared is equal to 3 squared plus 4 squared in meters, of course. So that's going to be 9 plus 16. So that gives us R is 5 meters. Okay. So we know what R is. And now let's plug in everything else. So it is going to be 9, 10 to the 9 Newton meter squared per coulomb squared. And then we are going to have times 7. Let me use 10 to the minus 6 coulombs times 2 10 to the minus 6 coulombs over 5 meter squared. Okay, so what's that going to give me? So 7 times 2, that's 14, times 9, that's 126, divided by 5 squared, that's divided by 25, that gives us 504. I'm carrying more digits than what I need in terms of what I should do in terms of the significant figures, but Let's stick to that. So we have 10 to the 9 here, minus 6, minus 6. So that's minus 12 and 9, so times 10 to the minus 3 newtons. Okay, that's my force, F13. What about F23? So it's going to be K, Q2, Q3 over R squared. One thing nice, because of the symmetry in this question, R is going to be the same, so we don't have to calculate that. So the only difference, we are going to have 3.5 instead of the 7. Again, we are going to use positive values. So if you calculate that, it should be just half as much of what we found in the previous question, because we have half as much the charge when we use Q2 instead of Q1. So we should find 2.52 10 to the minus 3 newtons. Okay, that's wonderful. Okay, now I'm going to erase a little bit these and try to do the important part. Okay, what we said here, I'm going to write them on top. We said F13 in magnitude is 5.04 10 to the minus 3 newtons, and F23 is 2.52 10 to the minus 3 newtons. I'm going to try to erase these. Come on. Come on, buddy. Can do it quicker. We need the space, that's why I'm erasing. Okay, so now let's check what's going to happen with the forces. F13, that's the force exerted by charge 1 on charge 3. Now these two charges are identical, so they are going to repel. That means that the force is going to be along the direction of R, but moving away from charge 1. That's the direction of F13. Now let's check F23. Now remember, this is my R for F23. Now, positive charge, negative charge, which means they are going to attract. If they are going to attract, that means my force is going to point this way. That's my F23. Okay? So now if I'm going to add them, my overall force is F13 plus F23, which means I have to add them like I've learned to add vectors. Okay, so the way I'm going to do it, I'm going to use a table. X component, Y component, and F13, F23, and F. Okay, now to be able to do that, I need to figure out the directions. So if I choose this as my x-axis and this as my y-axis, now I need to figure out this angle and this angle. Now this angle, I can figure it out. This angle is the same as this angle, so I can figure it out using this triangle here. Tangent of that angle, if I call it theta, is equal to 4 over 3. So I do inverse tangent of 4 over 3. So that gives me an angle of 53.1. So that's this angle. Now, one thing nice is we are looking for this angle. And this angle is the same as this angle, which is the same as the 53.1. So we don't have to calculate it in this case. We don't have to do anything else in this case. Okay, now, so what's the x component of f13? Okay, you notice here it is positive, so it's going to be the 5.04 10 to the minus 3 times cosine of 53.1. So it's going to be, let me do the 10 to the minus 3 here so I don't have to carry it here. So it's going to be 5.04 times cosine of 53.1. And that's going to be, in our case, let's see, .02 millinewtons, since we have the 10 to the minus 3 there. Okay, now let's do that the same thing for F23 first, the x component. So it's going to be 2.52 times cosine of 53.1, and that's going to be 1.51 millinewtons. So my overall force along the x is going to be the sum of both of these, which is going to be 4.53 millinewtons. Now let's check the y component. So we are going to have 5.04 times sine of 53, and it is positive. So that's going to be 4.03 millinewtons, and then for the other one it's going to be minus, since it's pointed down, 2.52 sine of 53.1, and that's going to be minus 2.02. So when I add them up, I should get 2.02 millinewtons. Okay, so what's the magnitude of my force? It's going to be square root of 4.53 squared plus 2.02 squared millinewtons. That gives us about 4.96 millinewtons. Okay, so that's the magnitude of my force. Now to find the direction, I do the inverse tangent. So my angle is going to be tangent minus 1 of the y over the x. So it's going to be 2.02 over 4.53. that gives us a theta of 24 degrees. Okay, that's our answer for this question.